lot of excitement leading into GPT-5. I'm wondering what the energy is like internally at OpenAI leading up to such a big launch.
We have a research roadmap. In the last several years, this roadmap hasn't changed much at all.
Interesting.
It's able to cut the thinking time that it needs to extract the information by several factors.
You are head of research. So how do you personally balance that tension between the product side of the organization and the research side?
One thing that we're really excited is to kind of raise the bar in terms of what we consider acceptable for open source.
Let's talk about some of the lessons that you learned from GPT-4.
And GPT-5 is one of the first models we have that marries both the pre-training paradigm and the reasoning paradigm together. We do believe that this technology is going to raise the quality of life for most people.
Mark, thanks for joining me today. Good to see you again.
Great to see you, Matt.
So I want to start with a broad question, which is there's a lot of excitement leading into GPT-5. I'm wondering what the energy is like internally at OpenAI in the months and then more recently weeks leading up to such a big launch, such an important model. What is that energy like? What is it like inside of the company?
Every single launch, it comes with high emotion, right? And, you have that feeling when you're setting out to do a project where people are excited. And then, you have a period in the middle where there's always this kind of internal uncertainty, right? Is this model going to be good? Is it going to kind of hit the expectations? And then kind of really seeing kind of near the home stretch, everything come together. The energy picks back up. And I would say right now, the feelings are very strong. People are excited to get this model out. And we're excited to show it to the world.
Yeah, I've tested it and it is absolutely incredible. And I'm really just starting to figure out where kind of it really excels, where its personality and the tone and everything are. So, but I visited you guys a few weeks ago and Greg Brockman had mentioned that OpenAI still sees itself as a research lab and you are head of research. So how do you personally balance that kind of tension between the product side of the organization and the research side of the organization?
Yeah, I think it's important to take stock of, we're here to do research and the research really is the product, right? Every time we make a big breakthrough, that is something that will lead to a lot of value and utility for people. And of course, the product itself enables us to do more research, right? So I think these two things go hand in hand. It's a delicate balance. You really don't have one without the other. And that's kind of the view that I hold in my head. We want our research to have contact with the world. We want people to be able to experience kind of all this intelligence that we're building. And we're very lucky that it's resulted in a very successful product too.
Let's talk about some of the lessons that you learned from GPT-4 and how you applied it to GPT-5. So from an outsider's perspective, there doesn't seem to be a large amount of new publicly available data that can be applied to a brand new foundation model. Is that a correct assumption? And if so, how did you solve that data scarcity problem?
Right. So I would say it's somewhat accurate, but not fully accurate. You can always improve and expand the envelope of the data that you put into the model. So we're always looking for more sources of publicly available data, more sources where we can license data from. But I do think there's some couple axes by which GPT-4 is and GPT-5 differ. So when you look at GPT-4, it's really this culmination of scaling the pre-training paradigm. And GPT-5 is one of the first models we have that marries both the pre-training paradigm and the reasoning paradigm together. So it really heavily leans on our O series of models as well. And one of our philosophies here is we want people to get reasoning when they need it and get a very fast response when that's the more appropriate mode to be in. And they don't have to kind of pick, hey, do I need reasoning for this? Do I not need reasoning for this? And back to the question of data. One thing that we've also been exploring in GPT-5 is the use of synthetic data. And this is data that isn't written by humans, but is generated by models. And we've had a very healthy synthetic data program led by one of our researchers, Sebastian Bubeck. And, it's bearing fruits and it helps us improve coverage in areas that we really want GPT-5 to shine.
Yeah. Okay. So I was going to ask you all about synthetic data. So let's skip to that. One of my questions was, are you using synthetic data? Obviously, the answer is yes. There are some folks in the industry who say synthetic data and models trained on synthetic data from prior generations of models can only really be marginally better than their predecessor. What do you think about that? What's your take there? So how do you think about the synthetic data in future generations?
Right. I mean, we really do believe in the potential for synthetic data to be, higher quality and to improve the model in meaningful ways beyond just kind of really broadening or kind of deepening surface level knowledge in a particular category. Of course, this is a research program we're still pursuing. I think still has a lot of room to go. But I think we've seen enough signs of life that we've decided to use some of that to power GPT-5.
And are you able to speak to the mix of synthetic versus human data for GPT-5 and maybe how that compares to the mix for GPT-4?
I do think the exact mix is something that we want to keep to ourselves, but over time it's becoming more and more.
Are there any categories of knowledge where synthetic data really excels? Are there any categories of knowledge like math, science, coding? Those seem like maybe the obvious ones, but you tell me, where does synthetic data really work and maybe where does it fall short?
Right. And I think fundamentally, I believe in the promise of synthetic data in a very broad-based setting. And it's really kind of up to us to choose which domains that we really want to kind of unleash our set of tools on. We care a lot about code in the GPT-5 release, and certainly that's one of the areas that we've emphasized. But it's by no means the only way that we've used synthetic data.
Okay. And just to continue on that, are there areas that synthetic data have fallen short for you, or that you maybe wouldn't apply synthetic data to?
I don't think so. And I mean, there's certainly areas that are more amenable, but I don't think that we consider the techniques in synthetic data to be not general in a deep sense.
So as let's rewind months, maybe even years, when you start thinking about the architecture for GPT-5, what are some of the early bets that you made that maybe at the time you were a little bit nervous that hadn't been proven yet and ended up really working out?
With a big model like this, right? It's going to be the coming together of a lot of advances in architecture, in optimization, in reasoning, and even just kind of in the core infrastructure that we're building. So, we have teams that are exploratory teams in all of these domains, right? Exploratory architecture teams, exploratory optimization teams. And in the early phases of a project like this, they're coming up with their scattershot set of ideas. And over time, we refine those to the bets that are really working. And it's nice to kind of see that kind of winnowing of the ideas and the refinement of some of these ideas. And you integrate them all together, and it creates this thing that's really kind of a combination of a lot of these innovations on all of these axes.
Were there any early bets that really surprised you, though? Like you didn't know it was going to work, or you had some doubts, and then you just saw incredible results from it?
Yeah, I mean, one thing that I want to stress is kind of the coming together of reasoning and pre-training here. And that might sound pretty obvious on the surface, right? Like, why can't you just kind of get the best of both worlds very, very easily? There's actually a lot of work done by our post-training team led by Max Schwartzer. And, it took a lot of work to make these reasoning models a lot faster, a lot more robust, a lot more reliable, so that we could be able to combine both of these two paradigms that we've been working on somewhat independently into one surface that, people can access the best of both worlds with.
When you're thinking about where to invest your compute in pre-training versus RL, how do you think about that mixture? As a decision of really compute investment and really monetary investment because of compute?
Right. So, I mean, today we invest heavily in both, right? And it's really a function of, on the RL side, it's a new paradigm. There's a lot of very promising work, a lot of kind of like GPT-2 era style work of just exploring all of the different things that, influence RL. And it feels very early, right? And so there's a lot of things to explore. But at the same time, on the pre-training side, there's also a lot of energy right now, right? There's the work in synthetic data, like what I just talked about. And I think still a lot of work, healthy work in optimization and in architecture. As
you're training the model, as you're doing post-training on the model, how do you decide when a snapshot is like, hey, this is the one we're going with? And because obviously you're going to continue to improve it. That's what you guys do. But like, how do you decide this is the one we're putting out? It's ready, it's baked. and we'll wait for subsequent iterations for the next versions.
Yeah, well, I mean, I think it's a little bit of an art, right? And you want to strike this balance of, you want to pursue perfection. You want to pursue something that, it doesn't have kind of any kind of nitpicks or any, you play around with the models a lot. It has to pass the vibe check. And it shouldn't have any kind of small pathologies or, like any behavior that you're worried about. And you have to toe the line of kind of, waiting too long and kind of training what you consider the perfect model on all axes, and something that just like feels good and ready to play. So I think we've struck a good balance here, and the post-training team does a great job of kind of vibe checking all the checkpoints.
All right. You mentioned vibe check. What is Mark Chen's vibe check? How do you make sure that the model is good for you, for your personal life, for your work life? What does your vibe test look like? Yeah,
I mean, I check it on a couple of different axes. There are a couple of math problems that are my go-to math problems. Can
you share?
Oh, sure. So there's a fun one that I think I shared on Twitter a while back. But it has a very simple description. Basically, you want to create a random number generator, uniform random number generator modulo 42. And you have access to random number generators modulo every single prime less than 42. And this is actually still a relatively unknown problem. A lot of models, I think, still can't get this consistently right. But you can see a progression of solutions until you get to the most optimal solution here. And you can kind of see improvement in models in terms of how creative they are in being able to generate steps towards the best solution here.
Yeah. Yes. I understand those cutting edge math problems, the frontier math problems, the ones that are really hard. Do you have anything that is more like day-to-day vibe tests?
So I think I have two others. One are just kind of generating user interfaces, right? A lot of kind of physical simulations that are very visual, right? You can quickly get a test for like, does the physics look right? I think you see classic examples of this of balls bouncing around hexagons, but you can also do kind of like fluid simulations or other kind of user interfaces. And that gives you a sense for how powerful is the model, how good is the underlying physics, and how good is it as kind of generating robust code and aesthetic code. Another thing that I like to test it with is creative writing. I write a lot day to day as well, and sometimes probably one of the biggest use cases I use personally in my day to day is having ChatGPT comment on, revise, as a thought partner in documents that I write. And so we really just kind of like, does it have an intuitive grasp for what good style is? Is it persuasive? Is it compelling? Those are kind of the things that I kind of test for.
Did you see a noticeable improvement from GPT-4 to GPT-5 for creative writing?
Yeah, I do. And I think other users will notice that too.
Do you ever test humor, comedy? I always find the models struggle with that. So that's like kind of the golden benchmark for me.
Yeah, I mean, I think there was a time in GPT-2, GPT-3 era where the models weren't generating that realistic human text. And it would be funny in this kind of like, it's just a little bit off. But I think now that, we're in much more realistic text land, it might take a little bit of time before the models become funny again.
Yeah. A lot of dad jokes I've noticed.
Yeah. I think it's getting better. The reasoning models are surprisingly good at humor. I do think that ultimately could be a good test of reasoning, right? Can you kind of like figure out deeply what makes something funny?
One thing that I use models for frequently is getting life advice. And I don't know if you do this as well, but some complex situation in my life where there's different kind of angles I need to think about it on, and it's kind of a difficult decision. It just helps me understand all of those angles, helps me understand maybe something I hadn't thought of, a new way to approach the problem. Do you ever use it for that?
Yeah, no, I love it as a brainstorming partner. And it's, when you need advice on a situation, when you have some kind of complex problem where, there's pros and cons of every single kind of decision you could take. Sometimes use it as kind of someone you can confide in, right? It oftentimes provides some interesting perspectives.
Over the last few months, even back to the beginning of the year, China has open sourced a number of incredible models. They've made a lot of innovations on efficiency. Did you take any lessons or techniques from those open source models, open source papers as they were coming out and apply them to GPT-5, or like how has it adjusted your thinking and your approach to your own internal models?
Right. So one thing that I'm very proud of at OpenAI is that we have a research roadmap. It's something that we put a lot of effort into, and it scopes out kind of what path that we want to take towards AGI. And it prescribes a couple of things you want to do in the short and medium term, but also in the long term. And in the last several years, this roadmap hasn't changed much at all. And it still hasn't changed.
Interesting.
Yeah. Even in light of model releases from DeepSeek and others. And I think that's really one of the strengths at OpenAI, right? We have conviction in the path that we want to take. We know what kind of ideas it implies, and we just pursue those ideas. And we're not a very reactionary company in our research roadmap. And at the same time, Chinese labs have been doing really great work too, right? Like I think DeepSeek in particular, they do phenomenal architecture research. They write very, very efficient kernels. And I think there's kind of lessons you can learn from that. But by and large, the research roadmap hasn't changed. And we are still executing on kind of the plan that we had 6 months ago, a year ago.
Yeah, that's actually kind of surprising to hear. So I assume the research roadmap is more broad categories of achievements you're looking to make, like a certain amount of efficiency, or are they specific techniques that you're looking to test and implement?
It really did inform kind of the development of reasoning models to begin with. And this is really one of, I think, OpenAI's proudest achievements over the last year, just the ability to create models that can think deeply, to reason for longer and longer periods of time before coming up with very intelligent answers. We think that's a very core part of developing general intelligence. And that's something that we've been pushing on and kind of developing independently of what's going on outside.
Okay. All right. So let's talk about GPT-5 a little bit more, and as it compares to GPT-4. Were there any emergent capabilities with the new architecture, the new training flow, that surprised you as you were starting to get towards the end of GPT-5 post-training?
Right. Again, I think a lot of these things will take some time to tell, right? When we launch a new model into the world, it takes a lot of experimentation, and the world discovers a lot of these things for us. One of the things that you can notice right off the bat is the coding is much better, right? Like people prefer the coding capabilities of GPT-5 with, I think 70+% win rate over our previous set of models like 4.0 and 0.3. So you really see that step up in terms of coding capabilities. And so I do think developers, right, they're going to notice the difference here. And it's just much more robust code. It's a model that, hallucinates a lot less. It's more reliable. You can trust the reasoning for longer and longer periods of time. It's much better at agentic tool calling. So a lot of these capabilities that people focus on for knowledge work, I think are going to improve, and people are going to notice that.
During my testing, there were two specific things that I noticed with respect to coding. One, the front end was just able to create much more beautiful front ends, visually appealing front ends. And then it was also outputting much longer code when I was just like single turn, much longer code. I think previously when I was using GPT-4o and even the thinking models, it would start to max out around like 500, 600 lines of code. But GPT-5 is certainly pushing well past 1,000 lines of code in a single turn. So it's really interesting. Was that a decision? Is there a certain training technique that you needed to elicit longer chunks of code from the model?
Yeah, I think one important thing about GPT-5 is it's tailored for developers as well, right? We care about practical situations, which often involve long code bases, large pieces of code that are generated. And so we've put a lot of focus into things like long context too, the ability to handle real world long repositories.
Your colleague, Noam Brown, said he believes the future of AI is likely to be Omni model, one giant model to rule them all, versus many smaller, more specialized models. So just wondering, what's your take on that? Do you believe that? And maybe it's a mixture of both, but I want to hear what you think, Mark.
Funnily enough, I haven't talked to Noam directly about this before. I think it makes a lot of sense, right? Like, I think, having one big brain that's capable of everything, it's going to be able to kind of have submodules and learn submodules in the right way. But I do think at the same time, one thing that we aspire to build at OpenAI is organizational AI. When you look at the levels of AGI framework, we do kind of think in terms of organizations of AI agents working together to achieve and accomplish high level difficult objectives. And I think it's always been a fascinating question, right? Like, do organizations work better, or do kind of single entities work better? And I think it's still a very active area of research, and one that we hope to get more signal on in the near future.
You touched on agents, and I want to pull on that thread a bit. I have been talking about scaffolding being such an incredible opportunity for so many developers. But as you think about giant or kind of an Omni model that's going to start to eat some of that scaffolding, I guess my question is, how much improvement, how much headroom for improvement do you think is available for folks who want to build scaffolding on top of GPT-5?
I do think scaffolding will always need to be there in some sense to tailor models to a particular application. But the hope with what we're trying to do with building very general models is that we can kind of chip away at the need to provide very detailed, very complex scaffolding, right? I think a very intelligent model, it should be able to soak in all of that context and just be able to kind of tell what you want to do. And it should be able to thrive even with less information, right? Some of the scaffolding today is built to really engineer around deficiencies in the models. And we really hope that part of the work that we're doing on robustness, on reliability, can kind of remove the need for a lot of scaffolding and allow people to kind of more intuitively tailor models to their applications.
And one element of scaffolding is memory or context management. Mm-hmm. Do you think we can reach whatever your definition of artificial superintelligence or AGI, mm-hmm. whatever these kind of big milestones in AI are, without having memory as internally in the model? Do you think it's possible?
Yeah, I mean, I think there's just so much rich work that needs to be done with memory. Like clearly today, right? Like there's a context window for models, and that's one of the big limitations. And you would really love the model to be able to maintain memory and context over, a really, really long period of time, right? Like it should be able to fit code bases. It should be able to fit all of your, personal documents and thoughts and maybe even like everything that you see day to day, right? Visual signals. So all of these things are going to help the model make better decisions for you to allow you to kind of remove that scaffolding you're talking about, right? And really have the model act on your behalf autonomously without having to ping you all the time. So we believe kind of memory is a huge limitation, a huge thing to overcome to make the models even more useful in the future.
And do you think, let's say you had an infinite or like a very, very large context mm-hmm. window, is that the kind of the ultimate solution for memory? Or do you think there's some other architecture where memory is maybe baked more into the core model itself, and maybe the weights get updated dynamically? This is a little bit above my pay grade.
But there's a lot of implementation details, right, in terms of how you could do memory. And even when you say, hey, if we support a huge long context, is that sufficient? I mean, a lot of it rides on how you actually implement that long context, right? You need an architectural primitive that allows you to implement long context that's rich enough to actually integrate all of that past information. And so I think a lot of it comes down to the specific architecture that you develop. And yeah, it's stuff that we're always improving. You want to make the model that much more efficient at both synthesizing and being able to pull from early memory.
Speak for a second about multi-modality. What is available today in GPT-5? And then what do you have planned in the coming months, if you're able to share about different modalities for inputs?
So we still have the same multimodal feature set as our previous models. They can do images they can do audio. And so they're perceptual models, and they're also able to do kind of image generation. I do really kind of think of perception as a core part of intelligence. And one thing that we've highlighted in previous demos in 03 and 04 Mini, for instance, is the ability for a model to take a very complex image, to analyze it, to really find the important parts and extract and kind of foveate around the image and understand what's the most important part for answering the query. GPT-5 is much more efficient at doing the same kind of task. When you give it visual perception tasks, it's able to cut the kind of thinking time that it needs to extract the information by several factors. And that's kind of what we're seeing across the board in terms of GPT-5's reasoning ability. It's just much more efficient. It's faster at getting you the reasoning that you need for your task.
I believe I read you are one of the creators of the original Codex model, the coding model. Yeah, okay, cool. So, by the way, when I first saw GitHub Copilot, I was absolutely blown away. It was really the first time I'd ever seen something like that. When did you first realize how powerful AI models could be at coding? Was this always something you knew, or was there a certain moment in time where you knew it was just incredible at coding because of the amount of data out there?
I think one of the biggest reasons we focused on code when we were producing Codex is we really saw this as a way to accelerating our own work fundamentally, because a lot of the work that we do in research is implement and try out ideas, and the medium of that is code, right? And so we were all really inspired to work on coding models because that seemed like a way and a fast way to kind of accelerate our own progress. The problem back then is there wasn't any good way to measure progress on code generation back then. And part of developing Codex was also developing this evaluation mechanism for figuring out how do you compare code models, like what are the right benchmarks. I think today, it's much more mature. And we've also gone from, the problems that we could solve with the original Codex, which were very basic, 5 lines of code, to the IOI problems that we're solving today, right? Which are very complicated, 1,000-line programs, involve a lot of creativity. So I think the models have just come so far, and we still believe in them as really this vector for pushing scientific progress forward, as well as helping accelerate ourselves.
Yeah, and I mean, for all of the frontier labs, coding seems to be such an emphasis, such a focus. Mm-hmm. Is that because coding and even as an extension, math are the keys to more capable all-purpose models? Is that the piece of it that allows them to do reasoning at a much higher level?
Yeah, I mean, I think there are a lot of different ways to teach reasoning, right? Mathematics is also a very efficient way to learn reasoning. Physics. There are a lot of domains that require a lot of deep reasoning, even stuff like creative writing, right? Or telling jokes, like you said. But we do think of coding as specifically aligned because so much of our day-to-day involves coding, and also so much of the value that I think people give to the world today through technology is through code as well. So it's definitely an area of strategic importance, and one that I think a lot of us internally benefit from. It's
so scalable because it does have verifiable outputs. And so I want to talk about verifiers for a little bit. As part of GPT-5's training, outside of more verifiable domains like STEM, were you able to figure out ways to verify things like creative writing or humor, as we talked about, less or more subjective domains?
Yeah, I mean, I think that's always a big part of our research program. We're trying to make RL more generalizable. And one way to do that is try to find ways to make verifiers more generalizable as well. Kind of any RL system is going to require verifiers. And we're trying to make our RL systems as general as possible.
Can you share a little bit about how you thought about verifiers for GPT-5? Are you using LLM as a judge, or like anything you can share?
It's a mixture of a lot of approaches. Unfortunately, I think we'll share that at a later date.
Is there anything you want to cover, Mark? I have a couple more questions, but I want to make sure, like, if there's something especially cool that you're excited to talk about, we honestly, get there.
It's really just been an exciting month for us, right? I think we're coming off the heels of not just GPT-5 release, but there's also the open source release. And there we're just really excited that we've been able to squeeze all this capability into such a small model that's accessible for people who want to run models on-prem. And then kind of even before that, we've had some really good results at competitions like AtCoder and the IMO. And it's really kind of just confirmation that these broad-based reasoning models are able to achieve stronger and stronger results, right? We're continuing to raise the ceiling. And for me, the AtCoder result stands out just because it's the first top 3 result at a world-class tier kind of a math or programming competition. And I think there's just a world of difference between, like top 100 and top 3. So really, really kind of happy with the progress that the team's making, pushing into that top tier level of human level performance.
And so, like, how does achieving such good performance at IY or at Coder, how does that translate into more everyday use intelligence,
right?
Where people are actually going to see a difference?
Yeah, that's a really, really great question. And when we approach these two competitions, we didn't set out to create like, here's an IMO specific model that we're going to pump a ton of compute into, and all it can do is the IMO, right? We're creating fairly general models. We take general techniques, layer them on top of our reasoning models, and with a very small amount of tuning, if any, we create models that can really kind of perform at this level at the IMO and IOI. And I think some of the models that we use for math competitions, it's the same models that we're using in the coding competitions. So they really aren't these like very narrow, specific models. We care about a program of producing general intelligence. And so I think what you're seeing is what you're getting, right? These models are very good at these contests, but also just very good generally, right? We haven't done too much tuning for them.
Yeah, I mean, that kind of speaks to Gnome and yourself, what you thought about having kind of a generalized Omni model in the future. Because if it's good at all of these different types of very difficult tasks, and then those things are all inside one model, and then they can apply it to more everyday use. So definitely lines up with what you were speaking about.
Absolutely.
Let's talk a little bit about the open source models that were just released. Tell me why you are so excited about these two flavors of models, 20B, 120B. Why are you so excited, and how do they help progress OpenAI's mission?
Yeah. So I think in terms of just the sizes of the models, right, we're happy to deliver models which can run on a laptop and run on a phone, right? These are very, very commonplace kind of consumer form factors. And it's really just going to allow a lot of hobbyists to become more involved. People with kind of very specialized constraints, academics, right? They're going to be able to access models which they have full control over. And I think that's going to be very powerful. And in terms of how it advances our goals, one thing that we're really excited is to kind of raise the bar in terms of what we consider acceptable for release for open source. And we've done a lot of extensive safety work on this model. What I mean here is, we have a preparedness framework, which allows us to think about risk for models. Like, is it risky from a bio perspective, or from a chemical perspective, or from a cybersecurity perspective? And what we've done with these open source models is to just test, right? Like, if some actor decided to fine tune one of these models to be maximally dangerous in terms of like cybersecurity, or being able to attack, code offensively, what is kind of the ceiling there, right? And we're making sure that it passes under the bar of what we consider high levels of danger before we release this model. So I think it's really a good chance to set norms for what is safe and responsible to release in open source. At the same time, right, we're releasing a frontier class open source model.
Yeah. No, I'm super excited to test it out. I obviously read all about it already. What went into the decision of the total number of parameters? I think obviously it's what can fit on consumer grade hardware, but then also the active parameters. How did you decide what that ratio looks like?
I think really it is just motivated by the surfaces and by latency. Like, we just want it to be very easy for people to run. And I think that really just drove all of the decisions in the open source model. We've engaged with developers very early on in the process. We've taken a lot of input, even starting from, I think, 2 or 3 months ago. And I think a lot of those conversations were very helpful in terms of parameterizing the model.
The benchmarks are very impressive, right? Comparable to O3 Mini, sometimes O4 Mini. Let's talk about benchmarks a little bit. You spoke about GPT-5 or a model getting close to winning the @Coder second place, getting gold medal at IOI. How do you think about benchmarks going forward when many of these benchmarks are saturated, but you have things like the ArcAGI benchmark, which is still pretty far off? What are your favorite benchmarks? How do you think about benchmarks and how these benchmarks kind of tell the story of the model capabilities?
You're absolutely right that there is a bit of a crisis when it comes to benchmarks today, right? And What I mean is that we used to be able to take hard benchmarks written by humans and just use them to test the models as well. And as the models get really to that frontier of what humans can do, the human benchmarks are not going to cut it anymore, right? Like I think like today, no one will be surprised if it could get a very good score on the SAT anymore, right?
Right.
And so now you've had to develop a lot of new types of benchmarks just to test the frontier capabilities of the models. And the problem is that there's no kind of standard or agreed upon way to do this, right? People are putting it together in the last just couple of years. We do a lot of that work ourselves too, right? And I think over time, some of these things will become more and more standard. But the danger too is that, they tend to have fairly short shelf lives these days. When you see kind of any benchmark that starts with, just a couple percentage points of accuracy, oftentimes within a year, you're already getting into like 30 to 50%. And so I do think kind of the shelf life of benchmarks has really reduced quite a bit. And we spend a lot of active effort in just creating orthogonal new types of benchmarks to challenge our models.
And what do you think about interactive benchmarks like ArcAGI3, right? It's kind of an interactive game benchmark. And what do you think of these benchmarks that are more set up as gaming environments for the AI to play within?
Yeah, I mean, it's certainly a good test of our models. And I think there's a danger in just indexing too much in one specific benchmark. What we try to do is just develop these broad-based reasoning capabilities and then use all of these specific kind of thermometers to gauge whether we're making progress in a broad-based way. So I wouldn't say our approach really like takes one benchmark as front and center and optimizes that, but rather, we try to get a pulse on, what are all signal bearing benchmarks out there, design more ourselves, and just make sure that those are all kind of small signals that we're pushing in broad-based reasoning in the right way.
I have a lot of developers and engineers who watch my videos, and a lot of them are quite nervous as AI continues to get better, right? Second place at the ad coder competition. What do you tell, let's say, new graduates or students that are thinking about getting into coding as a career? What do you tell them? I assume you're optimistic, but don't let me put words in your mouth. What do you tell them to make them feel more confident about that as a career choice?
Yeah, I mean, I would say just lean into using the tools to accelerate yourself. That's what we think about at OpenAI as well, right? We ultimately want to build AI that can accelerate research. And I think part of that is just accelerating your own productivity, right? If you learn how to interface with the tools, if you learn how to make yourself 2x, 3x more effective, there's still a lot of value you bring with your ideas and with learning deeply how the technology works. So really lean into that, understand the mechanics, be able to contribute to the mechanics, and just accelerate yourself. I think that's probably one of the most important things going forward.
And then more generally, let's say not coding, but knowledge work. There, again, like a lot of people are very fearful of being automated away. Do you apply that same recommendation to general knowledge workers? Just learn the tools, and if so, why?
I think so. And it's always because I feel like the model's going to automate some surface, but it creates new surface for us to adapt to, right? We're not going to lie, we think this is going to transform the economy in significant ways, but we also believe that humans are very adaptable, right? We've always done it in the past. There have been very powerful productivity tools in the past. And I think the more that we adapt to them, we create new surface for us to work in. And I think ultimately, we do believe that this technology is going to raise both through scientific progress and just through economic means, right? The quality of life for most people. And I think that's one of the things that motivates all of us here.
Yeah, I love that. I love the very optimistic view. I'm very optimistic as well. Okay, so let's end on this question. What are you personally most excited about over the next 6 months? And then let's say over the next 24 months?
I would say in 6 months, I'm really excited to just continue the reasoning scaling paradigm, right? I think there's so many different ways that we see pumping more test time compute into the models and to have the models leverage test time compute effectively. There's a lot of different RL objectives that we're trying out. There's a lot of innovations in RL optimization that we're trying out, and there's a lot of different ways that we're looking into scaling RL. So it's still a field that is rich with ideas. That's kind of not mature in the sense that there's just one recipe. And we're really excited to kind of figure out all of those small details. And I would say in 2 years, I just think, we really can get to the point where these models are just as effective as, I am at doing AI research. And I'd love to create this system that, the AI is really kind of driving a lot of the innovations that make future systems more successful.
Yeah, self-improving AI is just such a cool concept to think about. And yeah, if it's able to discover new innovations in artificial intelligence, apply it to itself, and then continue to scale up from there, It's really just a function of how much compute you can throw at it.
Absolutely.
Mark, thank you so much for chatting with me today. It's been a pleasure. I really appreciate it.
Yeah, really, really enjoyed the chat. Thank you so much, Matt.